Hello everyone, today we're taking a look at Rhino and Grasshopper, and we're taking a look at how we can create a huge amount of people like this just by having this as a PNG or a random file, just an amount of people of silhouettes. So how can we transform this into this and as a smooth, seamless operation? So I already have this script set up, and as you see, it's quite big and there's a huge amount of people. And I'm going to delete those for the moment. And also the script right now here is the finished script, but obviously you can change the amount, for example, how dense they are like put together, how many there are, and we're going through the process of how the image will be converted into a usable file format for Rhino and for Grasshopper. So as you see right now, it's a way denser image, and it will still produce the same or like a result that we saw in this picture here. So what we basically need to do when we have this image here, we need to use an image converter that, for example, will be in Firefly, and that's a Grasshopper add-on, and we're looking at each of the pixel, and we're taking a look if the pixel is black or white or anything in between. So we can also merge out those kind of weird small things. And then we're going to create an outline through every person, smoothen it, and then distribute it around the area. Okay, so let's start. I might need to sometimes look back at these files in order that everything is correct. So we start with a new Rhino file or with a new Grasshopper file. And the first thing is that we're gonna search for a picture. The best way is for example, for people silhouettes. Go on Google, go on images, and obviously the people need to be separated, and it would be good if there's like no shadow like this in here. For example, this one seems to be quite okay, or maybe this one. So I guess we just take this one, save image as, put it in here, and the first thing we're gonna do is we're gonna import it into the Rhino environment. That's obviously very important, like here. So we're gonna use file, right click on it, set the one existing file, use that file that we just had, and then we need to have the plugin Firefly. Just show you quickly. Put for Rhino, and it would be Firefly. Is this the correct? Yeah, I think it should be the correct one. So yeah, it can visualize data, it can use and help you with some things. It's very useful to use, so I definitely recommend to download it. So in Firefly you can use under vision a load bitmap. You can just put it in here. So here right now you see the loaded bitmap, and this loaded bitmap will be decomposed, and now we're having all different, like this, like 200 for 40,000 different things, different channels from 0 to 255 in the X and Y resolution. And we also, we see the resolution of the image obviously. And so what we need to do, basically we need to analyze each of those pixels, if it is black or white or anything in between. So the way we're going to do is we're gonna first create just the points that this is gonna be settled on. So we're gonna just use construct point, and we're gonna use a series, and the series will be the amount of pixels there are in the X and in the Y direction. So here this will be the one in the x direction, so there will be 391, and it will be a step of 1 for the moment, even though I think we can still change that just in case. And then 726 in the y direction. So this will be, we can just connect to it like this, and in order for it to be correct, you can also like graft it. So now it is correctly displayed. So each of the points represents one different pixel, and every time. Okay. So now we have this amount of points correlates with the amount of channels that we have here, and we're gonna, in order for it to be viewed correctly, we're gonna use the custom preview tool, and we have the material here which needs to be an RGB color, and we can just use the RGB channel of this here. Whoops. And then we put it on a material, and it most likely either maybe, I think, incorrect now because I didn't use the correct, I didn't draft this color tree because this was still just one very flattened list. This actually might take a while, and yeah, so this I think did not work correctly as intended. So I'm just gonna go back. It needs to be the same amount or the same list length. Let's see, you see, as you see, it's not displayed correctly. It needs to be like cut in the same way the other things are cut as well. So that's one way of doing it. I think we can actually just do it, flatten it like this, and use the color of that. And as you see, it is displayed correctly. So it corresponds to the image that we have here, and it shows each single thing. As well, you see as well, you have some gray tones. This is because in the image it's probably not exactly cut in half, or there's some gray, some anti-aliasing going on, so that's completely normal. And the next thing now is we need to differentiate if something is white or something is black. And the way to do it is, for example, to just make a simple math statement. For example, if the first number, which is from the green channel, for example, is smaller than the second number, for example, let's say 100, or let's say 101 for the sake, then the result is true or false, and we're going to use a dispatch method in order to kick out the white ones or the black ones, in order to have the correct sample of pieces. So we're gonna use the list of points that we have here, and we're gonna use the dispatch pattern, and then we're gonna use another geometry one, and we see which one that gets taken. And as you see, I can delete this one and make this one invisible. It already takes the correct pieces that we want to have. The other one would be the reverse, so we obviously want this one. Now this is defined now, so this is pretty good for now, but what we need to do still is to create the correct outline so it gets cut together. And the problem is it's all just a bunch of flattened points, and there's no trees or lists that can define those things correctly. So a way of I got around that is basically just by creating a rectangle that is placed on each of those things, and this rectangle has the exact same size as the distance between the points. So basically it just fills those things up with points, and then we're gonna use the command region union, which after it will it might take a while, and even in some bigger files it might take a little bit longer, but it basically looks at each of the different rectangles, and if they're in the same region, they're gonna bind them together. And as you see now, we have a very nice clear outline in that matter, which works completely fine. This is exactly what we wanted. So let's just hide that. And in order for it not to be that like let's say like Minecrafty, we want to have it smoothen out a little bit, and a way to do that is, for example, with a rebuild curve, which is on the curve and basically division, no, curve, util, and then rebuild curve. And we actually might even use that. I think might be better for that one. Let me just see quickly if the reduction tool might be actually the one we should need to go for. No, I think we still need to go for this one. So I think good way is, for example, to in order for the rebuild curve command to work correctly, we want to have a certain division of the vertices amount of the curve. So we're gonna use the list length of the vertices that we exploded from the curve, and we just do a simple divider from that of a certain amount. So in order for that being correct, we might need to graft something here. As you see it here, it takes the points and it will make a nice, more or less smooth line through it. We could also make it that it's not how do you say, that it's like more of a smooth curve, but the problem is because we have to change it later to a mesh again, and meshes work with triangles. It might be better to just have it as this kind of polyline instead of a curve. Okay, so now we have our outlines, so that's pretty good. And we're gonna use the boundary surface tool in order to make that correct as well. And we actually might need to flatten that in order to get those lines out. It will automatically take those things out. If you don't have it flattened, it basically calculates each individually, but here it realizes that it's inside of one, so it basically makes it separate. Okay, good. Now we have our people that we want to use, and the next thing we have to do is we have to define the bottom of each of those things. I think there are several ways to because we need to basically put them upright. So we need to put a point here which basically rotates this thing upwards. So one way to do is by knowing the middle points. That's like one way to know the middle point, I guess, but let me actually, there might be also more sophisticated ways of getting that done. Okay, so we have the middle point, and now we need to pull this point as far south as possible. And I think a good way to do is that we create a line here which will pull the point all the way to the bottom, and then pull the point back as close as possible of each of those things. So a way to do is that we can just create a simple SDL command. That's like just a line, and construct a point at 0, 0, and the length will be the length of the image, which is the same one as this, and the direction will be into the X direction. Actually, this might be a little bit too long now. Yeah, we need to use the other one. Yeah, and now we want to pull this point here and pull it back there. So we're gonna use the, let me see again, closest point. Let me actually check really quickly which command I used in that case. I think it was a rather simple command. I am a little bit lost at the moment. Well, I think that could be, we could just wait. Pull point. Yeah, we can just pull point, this point here, and the geometry here. So now it's down here. And we basically do then the same way or the other way around. So that's the closest point, and that's the surface, and now we have the point on the exact point that we want to have it. Okay, well, I want to have this one still, please, thanks. And now we're gonna create a 3D rotate command in order for this to stand up straight. So it's just rotate 3D, and the angle will be 90 degrees, obviously. The center will be this point, and the axis have to be a x that goes into the x direction. So we can just use the SDL command again, and the axis will be the closest point, and like this, might be a bit long, but okay. The angle will be 90 degrees, and we need to change it here on degrees, and the center will be the point that we defined before. It will be the axis, and the geometry will be the surface here. And I need to put it here. And as you see now, it is defined on exactly the place that we want to have it. Okay, so that's now good. And the next thing we're gonna do is to create a surface, or like an amount, like a place. Before that with rectangles, but maybe we can also use it now with like polygons and stuff like this. So we're gonna create, actually pull a polyline that goes something like this. You can see like almost as if there would be like a street or something. And just for the sake of it, I'm also gonna place a small box to make it a little bit more realistic, more or less. It's kind of like a square situation. And we want to create those people and just randomize them on this place over here. Let me actually just make this a little bit bigger, because it might be like a more human scale. Yeah. Okay, good. Now we have the geometry that you want to fill. So we're gonna use the geometry, set up the geometry here, and then we need to most likely use the command populate geometry. And this would need not like the outline but the inline, so we need to use the boundary surface command, and with that we can populate the geometry here. And what we need to do is now is we need to create a sufficient amount of the people here, and then need to move them also like over there basically. So for example, we have now 101 piece of geometry here, and so we need to have 101 points that you move them from here to there, or like 101 geometries that need to be moved from A to B. So a way to do that is to well, first of all, we need to create the thing itself, so we can use the area command again and move this basically to the ground, to like the Z direction of 0. So we can just project it to the bottom. So this will be our point that we will be here, go here from there. So that's the first point. Then we need to be duplicating this data and the given geometry that we have as well. Actually, let me just flatten this just in case. So we need to duplicate this. If we say, okay, there will be at least one person, just to be safe, we duplicate it basically 214 times. So we have 240 times duplicated. You should not show that here, but it's like very lightweight, so it doesn't really matter. and we also need to duplicate this data as well at the same time. So now it's all duplicated 240 times, and we need to also cut the list until it is like 240 long, because right now it's like 2000 or something. So we're gonna use the series commands, make a series of the amounts of the how long, which items we need to take. So the 0 to 240th item that will be like used, and we're gonna use list index. No, that's not the correct one. List item, sorry, use list item. That will be the indexes that you have, and that will be the for this case the points, and we'd also need to have the people as well. And now we need to use the vector that moves from point 1 to point B. So this will be the first point, this will be to the second point, this will be the movement from the one to the other one, and then we're gonna use the motion, and then we're gonna use this one here. And as you see, it perfectly put those things all over there, and then you have a really nice well-defined area of people that you can use and that you can use without any problems. And the cool thing now is when you say, okay, I have this set of people and I'm seeing, okay, I don't know, I don't like those kind of people, let me look for some other ones again, maybe like let's see which one should be fine. Yeah, we can, for example, use those people here, and I'm saying, okay, this is fine, just gonna download this, and then we're gonna go back to the script. We're gonna change the file path, use this one. It will probably be a bit weird because as you see here, it will be like 1, 2, 3, 4, those will all be together, and 5. So this will be like only 5 different people instead of 9 that we had like in this previous one. And so after some calculating, because it needs to go through the whole calculation again, and depending on the things, it might take longer. As you see, it just changed to the other one, and now you have exactly those people that you have here. And as you see, it sticks those people here together. So we're gonna change that very quickly because I like the other one more. They're more diverse, more different people there. And there was also another thing, because you saw in this picture there was some kind of outline here that you saw, some outline of the people, some outline how you can have this like black thing around, as if you would have like a silhouette, almost like a paper thing. So the best way to do is basically by first I'm gonna just make a mesh out of it actually. So it's gonna be meshed already, and then we're gonna just bake it. And now we have the pieces here all in Rhino. And if you look at the rendered command, we're gonna quickly deactivate the view in Rhino. So now we already have all the people that we want to have here. But the thing is that I'm not happy yet with the way of how this is like portrayed. So I would like to have them like a silhouette around. And if I would be rendering at the moment, I think it wouldn't show up. But for example, if you go to Rhino, okay, I already have it here, but you go to the V-Ray tab under like the asset editor, and you go to diagrammatic, and then you go to tune, and then you drag and drop it in, and here you see this kind of thing, and it's very easy setup at the moment. It has a base, which is this one, and then the tune itself, which basically modifies the base layer. So we're gonna modify it with like a line width of 2. We define the line color as black, and then we also gonna make the toon all white, the base of the toon white, and now we have this toon with this like thick color surrounding it. You can also make it look bigger, and then we are just gonna apply, right click, apply to selection, and now we would be able to, if we press render, I think I will want to make it a little bit lower quality. Okay. And we're going to render now. We would be seeing the exact result that we had here. And I actually just want to quickly just arrange that thing correctly, how we had it here. And actually bump the quality a little bit. And if we go to the render tab now, we see the exact same result as we had with the other one, with each of the things being one item and being correctly at every place. And this is a very good way of taking your scenes and putting some people in there rather quickly and give them already some kind of life to it without needing to painstakingly go through it and do all the things like separately. And I think this is a very great way to do it. So yeah, thank you very much for watching. I hope that helped you. I think it's a very cool design technique. There's, in my last video, I made a example of a high-res rendering, and I actually also used kind of the same technique as you saw here. We kind of had like this people and have the silhouette which is out here, so I thought it would be cool if you can just, because I had to place those just one by one by one by one, and it would be just cool if I can just take whatever silhouettes I just find on the web like those, and I can just like cover like gigantic scapes of them without any problems. So I think that's a very good way to do it and to have this in a workflow like in a rather easy way. So yeah, thank you very much for watching, and see you in the next one. Bye bye.